In this video, we are going to look at quadratic functions and in particular some features of their graphs. A quadratic function has this sort of format where we have an x squared term, maybe we have an x term, and maybe we have a constant term. This is this x squared term, this is the linear term, and this is the constant term. We have to have an x squared term in order for it to be a quadratic. So we could have something like y equals x squared plus 3 would be a quadratic, but y equals x plus 3 would not be a quadratic. That would be a linear function. It has to have that x squared term. The graph of a quadratic is this parabola shape, and if the coefficient of our squared term is positive, our parabola is going to open up, and if the coefficient of our squared term is negative, our graph is going to open down. Now, these graphs have this U shape, and there's some features of each graph that are important to be able to identify. First, the place where it crosses the y-axis, that's called your y-intercept. The places where it crosses the x-axis, if it does, or maybe it just touches the x-axis, those are called our x-intercepts. This spot right here, that's where our U shape turns, or this spot right here, these are the vertex of our parabola. And that's an important spot to help us graph our parabola. You always have to know the vertex. This vertex, when you have a parabola that opens up, this vertex is going to be the min. And if your parabola opens down, the vertex is going to be a max. The last thing that's important to notice is if you look at the line that goes through that vertex, your graph is going to be a mirror image on either side of that line. That's called the axis of symmetry. If you have a point over here, you're going to have a corresponding point on the other side at that same y value. So let's look at how we would find those spots given a quadratic function. Our quadratic function is this one here, f of x equals 2x, or negative 2x squared plus 4x plus 3. And the first thing to notice is that the coefficient of our x squared term is negative, which means this parabola is going to open down. The first thing we're going to want to do is find the vertex, the y-intercept and x-intercepts, and then we're going to graph. When we're finding the vertex, we're always using the formula x equals negative b over 2a. There's actually other ways to do this, but this is how we're going to do it. This coefficient of our x squared, that's our a. So a is negative 2. The coefficient of our of our x term is our b, so that's going to be 4. And then the constant term here, that's going to be 3. If I wanted to find the vertex, I'm going to take negative b, so it's going to be negative 4 over 2 times a, that's negative 2. So the x coordinate of our vertex is negative 4 over negative 4, or 1. This is just one coordinate. We need to find the other coordinate. We need to find that y value. To find the y value, all we're going to do is we're going to plug our 1 into our function, or we're going to evaluate our function at 1. So we're going to have negative 2 times 1 squared plus 4 times 1 plus 3. So that's going to be negative 2 plus 4 plus 3. That's going to be 5. The y-coordinate of our point is 5. So our vertex is going to be at the point 1, 5. To find the y-intercept occurs at the place where it crosses that y-axis. At any point on the y-axis, your x is 0. To find the y-intercept, you're going to set x equals 0. So we're going to find our function at 0. That's going to be negative 2 times 0 squared plus 4 times 0 plus 3. It's 3. So the y-intercept is always that constant term. So let's find the x-intercepts next. So remember that when we're trying to find x-intercepts, these are the places on the graph where the graph either touches or crosses that x-axis. And at all points on the x-axis, the y value is 0. So what we need to do to find the x-intercepts is solve the equation 0 equals our function, our y, negative 2x squared plus 4x plus 3. Our methods for solving quadratic equations, we can either factor or we can use the quadratic formula. But the problem with quadratic formula is a little bit more complicated, but it always works. If you're good at factoring, it can be easier, but not all equations are going to be able to use that method. Let's go ahead and use the quadratic formula here. So our a is going to be negative 2, that's that value. Our b is this value, b is 4, and our c is this value. So remember the quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. And so if we plug in our answers for our a, b, and c, our values for a, b, and c, we're going to have negative 4 plus or minus 4 squared, that's going to be 16, minus 4 times a, which is negative 2, times c, which is 3, over 2 times negative 2. So we're going to have negative 4 plus or minus, if you simplify this part underneath the radical, that's called the radicand, that's going to give you 40 over negative 4. And we can actually simplify that. Remember, 40 is 4 times 10, and the square root of 4 is 2. So that's going to be negative 4 plus or minus 2 square roots of 10 over negative 4. And I can simplify this a little bit further by factoring out a negative 2 from both the numerator and the denominator. So if I factor out a negative 2, my numerator is going to look like 2. It's still going to be plus or minus the square root of 10 over negative 2 times 2. And then these two negatives to cancel. So we end up with x equals 2 plus or minus the square root of 10 over 2. So we usually have two different ways that we can express the intercepts. We can write it just as x equals the x value, or you can put the x value in so that you have an ordered pair. So we could have 2 plus square root of 10 over 2. And remember, the reason why we've got the 0 here is because every place where we have a y-intercept, our y is 0. I'm sorry, every place where we have an x-intercept, our y is 0. And then we'd have 2 minus the square root of 10 over 2. Okay, so let's take and put some of our points on our graph. So we have the vertex is at 1, 5. So that would be this point right here. We have the y-intercept is at 0, 3. That would be that point right there. And we have these two x-intercepts. I went ahead and estimated what the two values are, and one of them is about at negative 0.5 and the other one's about at 2.5. So notice that we have this is where our vertex is, so our graph is going to be symmetric on either side of this line. We could make maybe another point. If I plug in negative 1 and find the y value, I would have negative 2 times negative 1 squared plus 4 times negative 1 plus 3. So this would give me negative 2 minus 4 plus 3. So that would be negative 3. Let's go back to thinking about that idea of symmetry. So we have negative 1, negative 3. That's this point right here. So let's find the point that is symmetric. So if we have a y value here of negative 3, where this distance here from that vertex is 2 units that way, then if we went 2 units this way, we would also have a corresponding point there. So that would be at 3, negative 3, would have a corresponding point. Also notice here, this y value here is 1 unit away from our vertex horizontally. And so if I went 1 unit this way, we would also have another point. So that picks up those points that are the points of symmetry. So the last thing we're going to do is draw our graph. So we're going to connect our points here, and it looks mostly like that. So do your best to make this look like a curve. We don't want to see graphs that look like this. So it should not look like straight lines. So that's it for this video. Hopefully you found it helpful.